Could you repeat that? You're kind of glitching on my side.
Is it? Can you hear me now?
Come on, don't glitch now.
Hello, can you hear me? Zander, can you hear me?
Sir, are you there?
Yes, I
Yes,
can
sir.
hear you perfectly. Can you hear me?
Yes, sir, I can hear you now. Thank you.
Okay, brilliant. Okay, so what I'm going to do is I'm just going to go through the properties of quartz quickly. I'm not going to waste your time because this is learning work. I mean, you have to know this. It's not a question of maybe, or you know it 60% of the time, or whatever the case may be. You need to know this because in geometry, when you're going to be doing questions, we have to find unknown angles and so forth. If you don't know the properties, you're not going to know which angles are 90 degrees, what happens when you've got a rhombus, what happens with the diagonals and so on. So if they give you a figure and they tell you it is a parallelogram, you have to be able to go to that figure and mark everything that is the same, that you know, every single characteristic of a parallelogram. Okay, just give me a moment. Okay, so what we're going to do is first of all a square, and in the square, as I said, I'm not going to waste your time. In a square, you know that all the sides are exactly the same length. You also know that in a square, the sides are also parallel. And remember that if you've got parallel lines, you have got three other angles that you need to look out for. And that is your co-interior angles that add up to 180. It is your alternate angles, and it's also your corresponding angles. Okay, so in a square, we know that all these little angles in the corners, in the vertices, are all 90 degrees. Now, if we talk about 90 degrees, there's an ugly Greek person that you always need to think about, and that is Pythagoras, Pythagoras, Pythagoras. Because I tell you now how they're going to ask Pythagoras in the test, and it's not because I've seen your test, but they can use Pythagoras with a square, a rectangle, a rhombus, a kite, and a trapezium. So if I was your teacher, I would actually ask you a question about a rhombus and a kite, and put some unknown angles in there, and put some values of lines in there, lengths, and then ask you to work it out. So if you don't know that a square and a rhombus and a kite has got a few angles that are 90 degrees, then you are basically, you don't have a hope to get it done. Okay, so that is important. And what is also important in the rhombus is that all these sides, all these angles, these sides are equal, which means that all the little angles are equal as well. So all of those little angles are 45 degrees. Okay, you've got this with you in your textbook. So you just need to go and learn it. Okay, so for a square, all the sides are equal, all the angles are 90 degrees. The diagonals bisect, which means cut each other in half, and that always gives you 1, 2, 3, 4. It gives you 4 isosceles triangles. So all those little angles are exactly the same. That one there and that one there. All those little angles on the sides are exactly the same. Now, if you know that, you've got a fighting chance to actually do the questions on that. Okay, the same with a rectangle. We know that side is equal to that one. This side is equal to this one. I know this is a bit boring, but we have to go through this before we get to the other questions. We know those two sides are parallel. We also know these two sides are parallel. We also know those angles are equal to 90 degrees. If they tell you that something is a parallelogram, that's a rectangle, you can put in all these things. You can mark all these things. Okay, the same with let me just get another color. The same with the diagonals. The diagonals are exactly the same length. Exactly the same length. Which means that that angle and that angle will be equal. And that angle and that angle will be equal. Okay, and of course, that little angle and that angle and that angle and that angle, because you've got isosceles triangles there. So how do you learn this? You make the sketches just like I did it now, and then you go and put in all the information that you can think of. Okay, I'll show you now where we're going to be using all of this. The rhombus and the kite are the two that is asked most. Okay, so you can expect to see a rhombus or a kite. So the one thing about a rhombus that you need to remember is that if you draw in the diagonals of a rhombus, they bisect each other, but they do it at a 90-degree angle. That is the most important characteristic of a rhombus, because if you've got the lengths of the diagonals, you can just divide it by 2. But what is even more important is you've got 4 triangles that you can use Pythagoras in, because all of these triangles are right angle triangles. So Pythagoras is everywhere. Okay, so that's what makes this important. They're going to ask you Pythagoras questions out of this. Now remember, Pythagoras only works with right angle triangles. You cannot go and do it at any other triangle that you want to, only right angle triangles. Okay, and Pythagoras, if you've got any 2 sides, you can find a 3rd side. Right, other things about a rhombus, of course, we know that those are the same and those are the same and that they parallel. We know in this case that angle and that angle there will be the same. For a rhombus and a parallelogram, the opposite angles are always the same. And you don't have to go and tell them why. You can just tell them it is a characteristic of a rhombus. Okay, parallelogram. The diagonals also bisect, so that is equal to that, and that is equal to that over there. And of course, the sides are the same, and they parallel, which means you've got a lot of alternate angles and a lot of corresponding angles, and so forth. Okay, then the kite. Now, the kite is a important one, and the reason is because of the following characteristics. In a kite, those angles are always 90 degrees. And that means that you have got 4 triangles in which you can use Pythagoras. Okay, so keep that in mind. Also, you have in a kite, you've got that side is always equal to that side over there. This side is always equal to this side over here. And you've got, let me make it in a, you've got this side here is always equal to that side over there. Those 2 sides are always the same. Let me take another color. Green, let's make it a shocking pink. So that side over there is the same as that side over there. And you need to know that. You also need to know that that little angle is equal to that little angle. And of course, this angle is equal to this angle over here. So there's a lot to know that. At a trapezium, you've only got that those 2 sides are parallel. So you're going to have co-interior angles and all of that jazz. Okay, I just wanted to go through that very quickly before we actually start with what I want to do next. But this is learning work. So go back to your book and make sure that you learn this stuff so that you know it. Think about carrying around a little toolbox of mathematical tools. And if you get a mathematical problem, what you do is you reach into that toolbox and you take out a tool to solve that mathematical problem that you've got. But if you don't learn this, those mathematical tools will not be there and you'll never be able to solve the problem. The more tools you've got, the better you're going to be at solving the problems. Okay, then Pythagoras. Now, we've spoken about Pythagoras last term, so I don't want to waste time here, but Pythagoras only works with right angle triangles. You cannot do it in any other triangles. The angles have to be right angle triangles. So you must see that little 90 degrees there. If you don't have that there, then you cannot use Pythagoras. Okay? So Pythagoras only works with right angle triangles. So it doesn't matter what the right angle triangle looks like. All 3 of those that you see there are right angle triangles, and you can use Pythagoras in each of them. Right. Now, before you use Pythagoras, you need to know which side is the long side, the hypotenuse side. And that is always the side opposite the 90-degree angle. So that is my hypotenuse. That's the longest side in a right angle triangle. Okay, which means that this side and this side are shorter. And this side and this side, those are the 2 short sides over there. Okay, now think about this. It makes sense that if I want a big side, it would always be the sum of the other 2 sides. But if I want a shorter side, It will always be the difference between the other two sides. For example, let's say that we have got this little triangle over here. Let's say that's x, and this is 3, and this is 4 over here. Now, what Pythagoras says is that if I square the hypotenuse, in other words, if I square x, it will always be equal to the sum of the squares of the other two shorter sides. So that's Pythagoras. Okay, don't try and go and learn to do a formula there. You need to understand it. Okay, formulas are there to help you, but formulas are not there to learn. You have to learn to understand formulas. So Pythagoras said that if I take the hypotenuse squared, it will always be equal to the sum of the squares of the other two sides. So in this case, I wanted to find the bigger side, which makes sense to add the other two. So what would I do here? I would go and work this out. That's going to be 9 plus 16 over there. And I'm going to get that x squared is equal to 25. And then, of course, to get x alone, I'm just going to take the square root of 25. And that means that x is equal to 5. Okay. But you can also be asked a question that looks like this, for example. Let's say they give you that's 10, and they tell you this is 6, and now you have to get that is 8. Now remember, the longest side is the 10. Okay, so the x that I'm looking for is one of the shorter sides. And if I want a shorter side, I always subtract. If I want a longer side, I always add. So if I want a shorter side, then it's going to be x squared is equal to, write your minus down, then the longest side squared minus the other side squared. So you need to know which side is the longer side, and you need to know when do you add and when do you subtract. So you only add when you find the longer side, and you subtract when you find one of the shorter sides. So from here, I'm going to have x squared is equal to, and this is going to be 100 minus 36, and I'm going to get x squared is equal to 64. And then, of course, to get the square away, I'm going to have x is equal to the square root of 64, which is equal to 8. Okay, so that in a nutshell is Pythagoras. Of course, you will be asked it in this way, but most of your problems are going to be a little bit bigger than this, and I'm going to show you now what we mean by that. But before we get there, I want to see what you think. So what I want to do is I'm going to give you a chance to just take a look at it, and I'm going to put 2 triangles down here, and these triangles are going to be right angle triangles. And what you need to figure out is, what do I do to get the unknown side? Do I need to add? Do I need to subtract, or whatever? Because if you don't know that, then you can't do Pythagoras. Okay, so let's say, let me use, say we want x over there. Right, let me use a 5 there and a 12 there, and let's say I want to find x over there. Okay, so if you take a look at the first triangle, what am I trying to find? Am I trying to find a long side, or am I trying to find a short side? What do you think? Anybody want to take a chance?
Short side, sir.
I want to find a short side. Now, and if I want to find a short side, I always, what? Add or subtract?
Subtract, sir.
Always subtract, now. Always subtract. So I want to find a short side. So it's the longest side, which is 5 squared. How do I know it's the longest side? Because it's opposite the 90-degree angle. Nah? So that's my longest side. So it's going to be that minus 4 squared, the other short side squared. And then I'm just going to work it out, and I'll do it quickly here. It's 25 minus 16. So you get x squared is equal to 9, which means that x is equal to the square root of 9, which is going to be 3. Okay. I'll show you now how we're going to ask it. Right, then if we take a look at the one on the other side, now we want to find that x value there. Now that is my longest side in this triangle. The longest side is always opposite the 90-degree angle. So I'm going to have to plus to get it because it's a long side. So it will be x squared equal to, and then it will be 5 squared plus 12 squared. So I get x squared is equal to, and this is going to be 25. Plus 144, and that means that x squared is equal to, and that's going to be 169. And then it means x will be equal to the square root of 169, which means it will be equal to 13. Okay, so all I wanted you to do on this page and the previous page is know that Pythagoras is only for 90-degree angles. If a triangle is not a 90-degree angle, a 90-degree triangle, you cannot do Pythagoras. And you need to know that you're working with squares of sides when you're working with Pythagoras. And you need to know that when are you going to subtract and when are you going to add. Okay, right. Let me get rid of this quickly. And then what we're going to do is I'm going to give you a question where they are basically going to give you triangles that are also not right angle triangles. And you actually have to figure out what it is that you need to do. Okay, but before we do that, I want to do the following. Now, I think you'll get this in the test. Okay, I hope you're sitting up right now. And I don't think you're going to get it in the test because I've seen the test, but I would ask it as one of the questions. Okay, so what I can do is I can give you a triangle. Let's say ABC. And remember what I said now. We'll see if I'm right or not. I think this is going to be in the test, ABC. And I am going to give you the following lengths there. 25, 24, and 7. And my question is going to be, prove that triangle ABC is a right-angled triangle. Okay, that's my question. Prove that it's a right-angled triangle. Right. Now, the moment somebody says anything about a right-angled triangle, you think of Pythagoras. So if you think about it, if I can prove the theorem of Pythagoras is working in a triangle, then the triangle must be a right-angled triangle. That makes sense, doesn't it? So if I can prove that Pythagoras works in this triangle, it will be a right-angled triangle. And Pythagoras says that the square of the longest side is equal to the sum of the squares of the two shorter sides. Okay? So what I'm going to do is I'm going to square all the sides. That's the first thing I do. Remember, I have to prove Pythagoras. So let's square everything. We've got AB. AB is equal to 7. But we want square, so AB is equal to 7 squared, and that is equal to 49. And then we've got BC, and BC squared is equal to 24 squared, and that, if you work it out, I think is 576. And then you've got the long side squared, so that's AC, and if you take AC, that's 25 squared, you're going to get 625. Okay, now why am I squaring the sides? It's because Pythagoras square the sides, no? So I square the sides. Now, when will this be a triangle that is a right angled? I need to prove that in this case, AC squared is equal to AB squared plus BC squared, isn't it? Just get rid of that little thingy there. There we go. BC squared. I have to prove that. I have to prove that AC squared is equal to AB squared. Now let's see if it is. Remember, AC squared, I've already worked out. AC squared, there it is 625. Okay, and AB squared I've worked out, and I got 576. And BC squared I worked out, and that is 49. And what happens if you're going to add these two? You're going to get 625, which is the same as that. Now, the only way that this can happen is if this is a right-angled triangle. So you have just proven that this triangle is a right angle triangle. And the reason for that is because the Pythagoras' theorem works for the triangle. So I can just clean this pen quickly. Okay, and I want you to have a good look at this one because I really think it's going to be in there. I would ask it, but if I want to prove any triangle a right angle triangle, first thing you do is square all the sides. And if you square all the sides, see if 2 of them adds up to the third one. And if it does, it means that you've proven that that triangle is a right angle triangle. Okay, any questions on this? Right.
Also, thank you.
Okay, so what we're going to do now is I'm just going to do 2 examples of where they can ask you to actually find where you can actually use Pythagoras. Okay, and then I'm going to move over to areas and perimeter. If we don't finish with perimeter and areas, we just continue on Monday. But let's take a look at Pythagoras. So the one that that they usually ask is something like this. Let's say this is A and B and C. B doesn't look good there. Let's get rid of that. Let's sort B out. There we are. They tell us this is 90 degrees. And they draw a line down over there. Let's make that D. They tell us this is 30. They tell us this is 24. And they tell us this is 10. And what they want is they want the length of DC. Now we've done one like this before. Okay, but it's one that they can ask you. So let's take a look at this first. Now look at what you are given. It is extremely important that you look at what you are given. And if you take a look, you are given the 30, you're given the 24, and you're given the 10 over there. You're also given that this angle is 90 degrees. Okay, one thing that's very important to note here is that this triangle over here, if you take a look at this triangle over here, that's not a right angle triangle. Okay, so you cannot use Pythagoras in that triangle. So I cannot, for example, say that 30 squared is equal to 24 squared, and that will give me DC. So if I'm going to do the following, if I'm going to say, well, DC squared is equal to, then that must be the longest side 30 squared minus that's 24 squared, that's going to be wrong. And the reason it's going to be wrong is because this is not a right angle triangle. That's not a right angle triangle. You've only got 2 right angle triangles. And it is this one. There is a right angle triangle, so you can use Pythagoras in that one. Or it is this one. It's a big one all the way to there and back. That's also a right angle triangle. So those are the only 2 triangles in which you can use Pythagoras. Okay, I forgot to give you something else here. Let's make this let's make this 6 meters over here. Okay, so I need to figure out how am I going to get DC. I cannot use the purple triangle because it's not a right angle triangle, so I can't use the 30 and the 24. But I can use the red triangle and I can use the yellow triangle. So now you have to form strategy. So it's not straightforward. So if you think about it, to get DC, why don't I just find the whole length using the big triangle, and then I find this length BD using the small triangle, and if I subtract the 2 of them, I am going to get the DC that I want. That's my strategy. Okay, so let's do that. Let me get my calculator closer. I'm going to do it very quickly. They give me, in this small triangle, they give me, that's a 10, and this is a 6 over here. Wait a minute. No, the 6 doesn't have to get in there. What is wrong here? Yeah, 6 doesn't have to be in there. Sorry, my mistake. Just get rid of that 6. There we go. Okay, so the 6 doesn't have to be in there. But in this triangle over here, this red triangle over here, I can find BD. So it's going to be BD squared is equal to. And BD squared is the long side, which is 24 squared, minus the other short side, which is 10 squared. And then you have to go and find BD. Now, to save time, I'm going to do it quickly, because you already know how to do it now. 136 square root of 476 equal to, this is going to give me a whole 21,8. So let's make this 21,8. So now I've got that value there is 21,8. So that's the small part over here. Now I need to find the big part, the whole thing. So I'm going to use the green triangle, and I'm going to work out the whole of BC down here. So if I do that, BC squared is equal to, remember the 30 is my longest side now. There's my triangle over there. So the 30 is my longest side. So that's going to be 30 squared minus 10 squared. And if I'm going to work out BC, I am going to get 900 minus 100, 800 square root, 800 equal to, so that's going to be 28, let's say 3. And then it's easy to find a small piece, because the small piece is going to be DC is equal to the whole of BC minus the smaller BD. So I just subtract the two, 28,3 minus 21,8, and I just get my answer. Okay. Look at this. Now, if you look at this and you think you understand it, I promise you I can ask you the same question tomorrow and you might not be able to do it. Remember that in mathematics, you can't ever do a problem if you haven't done it yourself from beginning to end. There's always something that you're not thinking about. Okay, so you have to go and look at this recording again, and you have to do this sum by yourself. One more question that I want to do that has to do with Pythagoras. And what I'm going to do here is I'm actually going to use a rhombus. So I'm going to give you the following. Now just bear with me. Let me first see what I'm going to do here. I'm going to give you this figure. A, B, C, D, and I'll give you these as well. And I'm going to tell you, I'm going to give you the following information. I'm going to tell you that AC is going to be equal to, let's say, 16 centimeter. And I'm going to tell you that BD is going to be equal to, just hold on a minute. Hi? Okay, senior node. I'm going to tell you that BD is equal to, let's say, 24 centimeters. Okay, and then the question is, find the length of a side. Okay, and then what I'm going to do is I'm even going to put some, let's say that's a 60 degrees over there. There we go. And I want to know what A is, I want to know what B is, and I want to know what the C is over here. Okay, and I want to know, what else do I want to know? Let's see, I'm going to have that, I'm going to have this, A, B, C, and let's make this D. So I want to know those angles as well. So what you see in front of you now is a rhombus. So they will tell you that this is a rhombus. So they're going to tell you that A, B, C, D is a rhombus. Now you won't be able to do anything here if you don't know what a rhombus is. Okay, so let's mark everything in a rhombus. Let's do a different color. In a rhombus, I know that that side is equal to this side and that side is equal to this side. Okay, but now wait a minute. They told me that AC is equal to 16. So if AC is equal to 16, then it means that must be equal to 8, and this must be equal to 8. Okay, so that we've got. I also know that this side is going to be equal to this side here, but they told me that BD is equal to 24. So then it means that this has to be 12, and that has to be 12. Okay, if I didn't know that the diagonals of a rhombus bisected, I wouldn't be able to do this question. Okay, still doesn't help me. because I still need to find the length of one of the sides. So let's take a triangle. Let's take this triangle over here, for example. I just need to find the length of one of the sides. So that means I need to find this length over here. Okay, this length over here. But I can't find that because this triangle is not a right angle triangle. Or is it? Because if you've got a rhombus says, a characteristic of a rhombus is that the diagonals bisect, but they bisect at a 90-degree angle. And then it means that in this triangle over here, you can use Pythagoras to find the value of DC. All of this would be impossible if you didn't know what a rhombus was. That's why you need to learn it. Okay, if you don't learn it, you won't be able to do the questions. So let's start then. So there's the 90-degree angle, and my side is DC, so that's my longest side. So I'm going to say DC squared is equal to, and I want the longest side, so it's the sum of the squares of the other two sides. So I'm going to get DC equal to, and if you work this out, that's going to be 64 plus, that's 144. So it's the square root of 208. Now that you can do all on your own because I know how you know how to work Pythagoras. That's not the problem. So that's 14,4 centimeters. So there you've got the length of one of the sides. Okay, if you look at everything else there as well, if you, for example, want to find A, that angle A over there, remember that angle is 90 degrees there now. So in that triangle over there, your angle A is going to be equal to 180 degrees because the three angles of a triangle adds up to 80 minus the 90-degree angle, which is that chappy over there, minus the 60 degrees which they've given me over there, and that means that angle A is going to be 30 degrees. And my reason is because it's the angles of a triangle which is equal to 180 degrees, or however you write it down. Okay, so that's A. And then if you want to find B, remember that this is parallel to this. Don't forget the fact that they're parallel, because if they're parallel, it means you've got corresponding angles and you've got co-interior angles and all of that as well. So if you take a look at, for example, this, there's a Z, and those two sides are parallel, which means that angle there will be equal to this angle over here, which means that this angle C looks like an A, but it's actually angle C. Angle C is also going to be equal to 60 degrees, and my reason is because it's an alternate angle. Okay, so now I've got the 60, but then your B is going to be equal to 30 degrees because those three angles add up to 180. We know that's 60, we know that's 90, so that has to be 30, and the reason is because three angles adds up to 180 degrees. Okay. Is there anybody who can tell me, let me just see here. Okay. Is there anybody who can tell me how on earth I'm going to find this D? This angle D. This one over here. Now everybody's going to start looking for alternate angles and all of that and all of that and all of that. You don't have to. You don't have to, because what else do you know about a rhombus? You know that in a rhombus, that whole angle is equal to that whole angle, and those small angles are also equal to each other. Okay? Those two angles, the opposite angles, are the same, and those two angles are also the same. So this angle over here is equal to this angle over here. In other words, this angle D is equal to this angle A. And you can write it down just like that. So you can say that angle D must be equal to, well, it's angle A, and we already know that's 30 degrees. And what is my reason? It is because it's a property of a rhombus. That's all you say. How did you get it? Because it is the property of a rhombus, and you said it was a rhombus. It has to be true. Okay, so there's a lot that can be asked about a rhombus. Okay, how are we doing? Are we still there? Are we still awake? Are we still fine? Hopefully. Ooh, I don't hear a yes. I think everybody's asleep. Christian, you're asleep. Christian?
No, sir, we're here.
Are you not? You're awake, you sure? Okay, so we've got about we've a little bit more than 15 minutes left. So what I'm going to do is I'm just going to quickly go through the areas in the perimeter with you. Okay, and then we're going to we see how far we're going to get. Now, remember that the difference between perimeter and area is the following. Let's say that I've got a figure that looks like this, for example. Okay, exactly the same figure. If I talk about perimeter and area, it's two different things. If you, for example, talk about perimeter, it means you start on one point and you walk around the perimeter of a figure. So if I want the perimeter of this figure, all I have to do is basically just add the lengths of these sides, and that is going to give me my perimeter. Okay. Area means painting. It means you take a brush and you're actually going to be painting this whole area. That's what area means. Okay, so if you work out perimeter, what you're going to get is that your perimeter will always be in, let's say, centimeters, or it will be in meters, or it will be in units. But if it's area, it will be in square centimeters, or square meters, or square units. Okay, so area is different than perimeter. Perimeter is just a walkabout, and area you're actually going to be painting everything. Right, so let's take a look then. If I want to find perimeter of everything that I've done, let me just get rid of that as well. Come on, there we go. You know, for example, if you're going to take a square, there's your square, and you know that the square are exactly the same, so let's call it S. Then you know that the perimeter of a square is going to be S plus S plus S plus S. So it's just going to be equal to 4S. Okay. You also know that the area of a perimeter is basically just length times breadth, but they're the same. So that's actually S squared. So for a square, that's your perimeter and your area. Okay, that you need to know. You also need to know that for a parallelogram, for example, let's say this is length and this is breadth. If I work out perimeter, just add them up. So it's going to be length. I'm starting to walk from here all the way to there. So it's going to be length, plus it's going to be breadth, plus I'm going to be walking around there to the length again, and I'm going to be walking over there, and it's going to be breadth again. Okay, so it's all the way around. So perimeter is equal to L plus L is 2L plus 2B. So that's my perimeter. Okay. If I look at area, my area is just going to be length times breadth. Okay. And that is my rectangle. Okay. So those things you've known. You've even known triangles. And then the new one that we're going to be doing is circles. So I want to get through that. So let's take a look at triangles. And triangles can be very, very, very catchy. So listen carefully. You get three kinds of triangles. Get a right angle triangle. You get a triangle that use angle. Acute angle triangle like this chap over here. And then you also get this triangle that looks like it's lying on the beach. And you have to work out area and so on. Now, perimeter is easy because all you need to do for perimeter is you just need to find that length and add it to that length and add it to this length, and voila, you've got your perimeter. So here as well, there to there to there, perimeter. There, add, perimeter. Now remember, this is 90 degrees as well, nah? So remember, Pythagoras is your friend. Okay? So Pythagoras is extremely, extremely important to remember because this is a right angle triangle and you can use Pythagoras in here. You might just need some of the unknown signs. So perimeter is easy. I just add everything. Area is the one that they usually ask, and your area is a half times base times height. Another way that you can write it is you can write it as base times height over 2. It's exactly the same thing. The reason it's a half is because it's half of a rectangle. And a rectangle is basically length times height, or base times height. So it's half of that. Okay, now what is important in a triangle is that you know exactly where your base and your height is. And remember always that your base is always perpendicular to your height. Okay, so in this first triangle, that would be my base. The base is the side that the triangle is resting on. So that's my base. In this one, that would be my base over there. And in that one, that would be my base over there. Okay, so where would my height be? In this triangle, that would be my height. Remember what we said. The height and the base are perpendicular, so it needs to have a 90 degree there. In the following one, if that is my base, look at the highest point that you've got, and that's the point over there. And from that point, you draw a line down. That is my height. From the highest point down a line, that is where my height is. That's the highest point of that triangle. So if you draw that down, and that's even outside the triangle, that is going to be my height. So that's my height over there. Switch back to this. So that's going to be my height over there. That's my base. That's the base there, and that is the height over there. That's the height over there, and that's the base over there. And it's very important that you understand that, because if you take a look at the third one here, for example, you need to know that is your base, and your perpendicular height is actually outside the triangle, but it's always from the top of the triangle down. From the top of the triangle down. Okay, and then the circle. Now there we've got Mr. Circle, and Mr. Circle has got what we call a radius, but it also has what we call a diameter. Okay, and we're not going to use diameter, we're going to use radius, because all the formulas are in terms of radii. But remember that your radius is basically just half of your diameter, or your diameter is just 2 times your radius. So if you've got the one, you can find the other one. It's not a problem. Now, here we've got for the circle, and this is new work for you now. Well, probably not if you've done it in the previous years, but for the circle, the perimeter is actually not called the perimeter. It is called the circumference. So everywhere else, for everything else, your perimeter is your perimeter. But for a circle, we call it circumference. And your circumference for a circle is all the way around. That's my circumference of a circle. Okay? And that circumference of a circle, circumference of the circle is equal to 2 times pi times radius. That's my circumference, 2 pi radius. Okay, your area is everything inside. In other words, if I take a paintbrush and I go and paint this circle, then that's my area. So all of that is my area over there. So my area is going to be pi times radius squared. Okay, so there's a difference between these two. So remember, this one is in meters or it's in centimeters or whatever. This one is the area, so this is in square meters or square centimeters or so on. But you need to know these formulas. So that is the perimeter and that is the area. Remember, the area is the one that's always squared. Okay, the one that's always squared, that is your area, because that's how you get the square on that side there as well. Right, so this one you need to know. Now it's easy to follow the formulas, but sometimes what you do is you get something like this. You get half a circle, something that looks like this, or you get a quarter circle, something that looks like this, or you even get a 3/4 of a circle that looks like this. Okay, so if we're talking about perimeter, perimeter here in the first circle is just going to be halfway around. And then remember, this line also includes our perimeter. So our perimeter would be halfway around and the straight line over here. In the next one, perimeter will be those two straight lines and the quarter circle around. And then for the last one, our perimeter will be those two lines and 3/4 of the circle around. Now, how on earth do I get 3/4 and a half and a quarter of a circle? So let's say I would work out area here. If I work out area here, it's going to be pi times radius squared. But because it's only half a circle, I'm just going to divide it by 2. In this one, this is going to be pi radius squared, but that's only a quarter circle, so I divide that by 4. Okay, the same with the circumference. I do the circumference and I divide it by 2, or the circumference and divide it by 4. Just don't forget to add those lines because they're also part of your perimeter. This last one, this area is going to be 3/4 of your usual area. So what you do is you work out your usual area and you multiply it by 3 and you divide it by 4. Or you just multiply it by 0.75. It doesn't really matter. Okay, it doesn't really matter. Okay, so we've got enough time just for me to do one more sum. So thank you so much for tuning in and listening to this. It will pay off. It definitely will in the end. You just need to keep at it. I know you're tired. You've had a whole day of school, and now you have to listen to me as well. But I'm going to do one more question, and then what I'm going to do is talk to you about what we're going to do on Monday. Okay, so one more question here. Let's see what we do. Let's say we have got something that looks like this. Right, that's what we've got. That doesn't look very good, but anyway, use your imagination, and that we've got. And I'm going to give you that this is, let's say, what should we do? No, that's not what we want to do. Let's say this is 10 centimeters over here. And let's say this is 20 centimeters over here. And let's say this is, no, wait, that's not 10. Let's get rid of that. Let's do something that works well. Let's say that's 8 centimeters. And let's say that this is a 10 centimeters over here. And what I want is, I want the area of the whole thing. Okay. Now it's easy to see that you can break it up. I mean, if you take a look at this area over here, that's just a triangle. So that area I can get. That area is just going to be a half times base times height. Okay. So where's my base? Well, my base is over there, which I don't have. And there's my height, which I do have. So how on earth am I going to get my base? But now remember, it's 90-degree triangle. Okay, a 90-degree triangle means I can use Pythagoras. I can use Pythagoras to find this length at the bottom here. Okay, so let's call it x. So let's first go and find that length there. So before we can do the area, we're going to have to go and find that. So x squared is equal to the 10 squared minus 8 squared. Okay, we've been through Pythagoras. So you know how it works. So it's 100 minus 64, which means you're going to get 36. And that means that x is going to be equal to 6 centimeters. So now I can work out the area. Area is going to be a half times my base, which we know now is 6, times my height, which is 8. And that is going to be 24 square centimeters. Right. So there I've got that area over there. Now I need the area of this thing. Now that one is very easy because that area is just going to be length times breadth. So that's going to be 20 times 10. And that's going to be 200 square centimeters. So that is the area of that chap. And then we're going to work out that area of that circle downstairs. But I know that's half a circle. So all I have to do is I have to work out the area of that circle and then divide it by 2. But to do that, I need the radius. Now remember, I know this is 8. Okay, I know that length is 8 because this is a rectangle and this other side is 8. So that has to be 8. But don't use 8 because 8 is the diameter of that circle. Okay, 8 is the diameter of the circle. You're looking for the radius, which is just half of that. So your radius is going to be 4. So let's work out your area is going to be pi times, and then it's going to be radius, which is 4 squared. But remember, you want to divide this by 2 because it's half a circle. So if you're going to do that, it's shift pi times, that's going to be 16, and all of that divided by 2. And that's going to become 25,13 square centimeter. And then you can just add up all of them. You take the 200 square centimeter, you add the 24 square centimeter, and you add the 25,13 square centimeter, and you have got the area of the whole thing. Okay, right. So what I'm planning to do on Monday, in the first half hour or so on, is I want to do a few more exercises here because they can ask you figures with holes in them. Or they can actually give you the area and ask you a base or ask you a perimeter. So the first half hour of Monday, I'm going to use just to explain what we do then. And then if you haven't got questions, then I'm going to use the rest of the time looking at certain questions that we're going to be solving together, which is chapter 1 and chapter 2. Okay, and then after that, any questions that you might have, we can take a look at. Just make sure that you go and look at what we've done today so that it is not something that you're going to forget. Remember, when you do something, always remember it's part of your shorter memory. And your shorter memory only runs for 24 to 48 hours. So what you see now, you're going to remember for 24 or 48 hours. And then you're going to forget it again. Okay, that's how it works. If you look at it again within the next 24 hours or 48 hours, and you just go through it again, you're going to remember it for much, much longer. Okay, so you need some elbow grease as well from your side. Okay, guys, that's everything that I've got today. I hope it was useful. Thank you so much for joining. And I'll send the invite out. Monday at 14:30, we will have the next class. Okay, thank you for joining. All the best.
Bye, sir.
Bye-bye.